Hi everyone, welcome back to Lulumath. This is a video on domain and range, but it's a bonus video and we're going to be talking specifically about a square root function. So you're going to want to have some background knowledge on domain and range, and there is a video at lulumath.com as well as the Lulumath YouTube channel if you would like to have a refresher on what domain and range are and how they are applied to relations and functions. So let's have a quick refresher on the definition of domain and range. So remember, domain is the set of all inputs or X values or independent values that satisfy a relation, and range is the set of all outputs or Y values or dependent values that satisfy the relation and the domain defined by it. So we want to determine the domain and range of the function y equals the square root of 2x minus 5. So just a tip reminder that when we find domain, sometimes it's easier to ask what doesn't work for X, what's not going to give me an output when I plug it in. So when we're asking ourselves these questions, let's try some examples. Let's see what happens. So let's try X equals 7, for example. So we would do y equals the square root of 2x minus 5, but instead of x, I would replace it with 7. So then 2 times 7 is 14, and 14 minus 5 is 9, so the square root of 9 is 3. I get an output that actually works. Yay! Let's try another example. So let's try x equals 10. So I would do y equals the square root of 2 multiplied by 10, and then I'd have a minus 5 at the end. Well, 2 times 10 is 20, and 20 minus 5 gives me 15. And although I cannot square root 15 evenly, it's still a number. It's still a real answer. So again, my output works here. Let's try another example. Let's do x equals 2. So here I would do y equals the square root of 2 multiplied by 2 minus 5. And then here 2 times 2 is 4. So I would get 4 minus 5. And then I would end up getting the square root of negative 1. Now, if I have the square root of negative 1, I can't take the square root of this value. My output does not work because it's not possible to take the square root of a negative number using real values. So what this is telling us is that if it's not possible to take a square root of negative numbers using real values, this expression under my square root symbol has to be equal to the number 0 or higher. This expression here, this 2x minus 5 here, has to be greater than or equal to 0 in order for us to have a value that is not negative. Well, that right there will help us to restrict our domain. This will tell us the domain. Now all we have to do is just isolate x. So I will add 5. So 2x is greater than or equal to 5. So x is greater than or equal to 5 over 2 because I'll divide everything by 2, or 2.5. Now let's take a look at our graph. So if you see here in our graph starts at 2.5 and it doesn't go any farther to the left of 2.5. This is the starting point on my x-axis. So our domain is x is an element of the reals such that x is greater than or equal to 2.5. If I plug in 2.5 or higher here, I will always get a number that I can actually square root. Now in interval notation, we will say it's from 2.5 to infinity, but it includes 2.5, so we put a closed bracket here, and it can't reach infinity, so we will put an open bracket there. Now for our range, if you notice, it does not go below the x-axis here. And the reason why it doesn't is because when I take the square root of a number, by definition, even though every square root has positive and a negative answer, we only take the positive answer when we're looking at a function, because if we look at the positive and the negatives, then it'll wrap around like this and then it won't pass the vertical line test. So by definition, it's only going to be 0 because the square root of 0 is 0, or anything above 0. So therefore, our range is y is an element of the reals such that y is greater than or equal to 0, Or we could say it's from 0 to infinity. Now, it's an element of the reals because when we take the square root of numbers, sometimes they'll be nice even numbers like 3. Sometimes they won't be nice even numbers like the square root of 15. But as long as it's a non-negative value under the square root, it is square rootable. And that's it for this video. If you have any questions, let us know in the comments below or at lulumath.com, where you can also find blank or completed notes for this video. If you found this video to be useful, please make sure to subscribe and share with others. Thank you, and we'll catch you next time. Bye.